Hi everyone. Today we are going to discuss about the problems from the lecture 4. Problems based on lecture 4. Uh, so, um, First question is find the power consumed by 11 ohm resistor. So, here this is the 11 ohm resistor. So we need to find out the power consumed by that 11 ohm resistor. So we know that equation for power is voltage into current or I squared R or V squared divided by R. So here we know the resistance. So we can use either I squared R or V squared divided by R for finding out the power consumption. So here we need to know either voltage across that 11 ohm resistor or current flowing through the 11 ohm resistor. How we can find out either current or voltage of 11 ohm resistor. So uh, here it is an application. This problem is an application of voltage division rule or current division rule. Anything you can use. First method, by using current division rule, um, how we can solve this problem. Uh, so, uh, for current division rule, we need to know the total current flowing through this circuit. If we know this current, we can find out the current flowing through 4 ohm resistor and 11 ohm resistor using current division. So, first we need to find out this total current I. So, for that we need to find out the total equivalent resistance of this circuit and find out current using the equation I is equal to V divided by R total. Then if we got that current value, we can use the current division rule to find out the current flowing through 11 ohm resistor. Then we can find out the power consumption. Then next is how we can use voltage division rule. Here if we are using voltage division rule, no need to find out this current flowing through this circuit. We have given 20 volt as the voltage across whole resistance combination. Then we can find out the equivalent resistance of this combination first and equivalent resistance of this combination. So that we can convert this circuit like this. Here 20 volt is applied across these two resistors, and this is for parallel 11 ohm and this will be 3 parallel 5 ohm. So by using voltage division rule, we can find out the voltage across uh, this resistance, that is 4 parallel 11 ohm resistance. So whatever be the voltage across this resistance, that will be the voltage across 4 ohm resistance as well as 11 ohm resistance, because both that resistors are in parallel. So whatever be the resistance across this point, that will be same as the voltage across 4 ohm as well as 11 ohm. So we can find out the voltage across 11 ohm and we can find out the power consumption. So you can do this problem according to current division as well as voltage division. Then second problem, find out the voltage across 7 ohm resistor. So here uh, this is the 7 ohm resistor. We need to find out the voltage across that resistance. So 25 volt is given. So first we need to find, or we can find this current by finding out the total resistance of this resistance combination. Then if we got this current, we can apply the current division rule at this path, that is this total current is current we can find out using the equation I is equal to V divided by R total. Then if we got this current by applying current division rule, we can find out the current flowing through these two paths separately. So if we find out the current flowing through this path, that current into 7 ohm will give the voltage across 7 ohm resistance. Okay, so like this you can solve this problem also. Then third question is, find out the voltage and current in all the resistances. There are 3 resistors, so we need to find out current through all these 3 resistors and voltage across all these 3 resistors. So first we need to find out the equivalent resistance, that is R total of this circuit, that is here 6 and 12 ohms are parallel. So first find out the equivalent resistance of this combination, and that resistance will be in series with 6 ohm resistance. So like that we can find out R total. Then if we got R total, we can find out the current flowing through this circuit, current I. If we got this current I, we can that will be the current flowing through 6 ohm resistance, and thus we can find out the voltage by using I into R. Then if we got this current, we can apply current division to find out I1 and I2. If we got I1 and I2, the voltages across 6 ohm and 12 ohm resistors can be found out. Okay, so like this problem can be also solved. So first 3 problems are based on voltage division and current division rules, and next problem is based on delta star and star delta conversions. Okay, here we need to find out the total resistance across A and B. So here uh, this is the point A and this is the point B. So we need to find out the equivalent resistance of this circuit. Um, so here um, uh, equivalent by using parallel and series combinations of resistors only, we can't solve this problem, because here uh, uh, this this resistance combinations, these combinations are not in parallel or not in series. This is actually in delta connection. Two delta connections are there. Here this is the point C, that is that 486 ohm resistors are in delta connection. This connection can be again redrawn like this. Okay, if we redrawn this circuit like this is 4 ohm, this is point A, this is point C, this is D, this is E, and this is B. So this is 4 ohm, this will be 8 ohms, this will be 6 ohm, this will be again 8 ohm, this will be again 4 ohm. So this is actually a delta connection, and this is again a delta connection. So for solving this problem, we need to apply delta to star conversion. Either this delta can be converted to star, or this delta can be converted to star. If we are converting the top delta to star, the circuit become, this is 4 ohm, and that delta only I have drawn. This is 4 ohm, this is 8 ohm, and this is 6 ohm. So if we are converting this delta to star, this circuit become here one resistance will come. So here there will be a resistance, here there will be another, here there will be another. Like this this circuit will change. So this 4, 8 and 6 ohms can be replaced with this connection. Okay, so this circuit again become, this is 4 ohm, this 4 ohm will be there, then this star connection will come, then remaining 8 and 4 ohms will be there. So this is the point D, this is C, this is A, this is E. So from D there the 8 ohm resistance will be there, and from E 4 ohm resistance will be there. Then this become B, that is this is 4 ohm, this is 8 ohm, this is 4 ohm. These values can be found out using the delta to star conversion equations. So this if these resistance values we have got, then these two resistors are in series connection. Okay. These two resistors are in series connection, so that can be added together, and this resistance and this 8 ohm will be in again series connection. So this path can be replaced with a single resistance, and again this become again single one. So final circuit become 4 ohm will be there, here one resistance will be there, here again another resistance, this become the final circuit. Here these two resistors are in series, these two are in parallel, then we can find out the R total. Okay, so this circuit will be modified to this circuit. Okay, using delta to star conversion. So this is the application for star delta and delta to star conversions. Without using only the parallel and series combinations, by using parallel and series combinations of resistors, we can't solve some problems. At the for such problems we need to apply star to delta or delta to star conversion. Okay, then fifth problem is again like that. There is two delta connections, any one of the delta connection can be converted to star and you can solve the problem. So the question is, find out the current drawn from the battery. So you need to change this equation, or you need to assume the battery voltage is 24 volt. Here battery voltage is not given. So assume battery voltage is 24 volt and find out the current drawn. So find out the current drawn. To find the current, we need to find out the equivalent resistance of this combination. So convert any one of the delta combination to star and do the problem. Okay. Thank you.